Hello ladies and gentlemen, I'm Carl Ross from the University of Portsmouth, United Kingdom. And today I'm going to do an ANSYS analysis of geometrical and material non-linearity of a corrugated vessel. And the date today is the 24th of February 2015. Topic of references, click on structural, click on OK, and then click on preprocessor, element type, add, edit, delete, add an element, and I'm going to use shell 93, 8 node 93. So I'll come down there, you can see it's shell 8 node 93, I'll press OK, and this is because I'm in ANSYS 11. If I'm in ANSYS 13, I've got to use shell 281, which is a slightly different input for the thickness. So I next go in for material properties, I'll go for material models, and then I'll go for structural, linear, elastic, isotropic, and I'll put in the Young's modulus, which is 2E5 megapascals, which is the same as Newton per millimeter squared, 2 times 10 to the 5, Pascal's ratio 0.3, done that, OK that, and I'll go for the non-linear bit. I'll go for non-linear, inelastic, rate independent, isotropic hardening, Mises plasticity, bilinear, and this yield stress is 250 megapascal, that's reasonable for mild steel, megapascal 250, and the tangent modulus, I'll make the 100th of the Young's modulus, so it's 2E3, it's fine, and that, okay, and we come out of this, and we put exit. We then go to the real constants, and put thickness in, add thickness, okay, one real constant, thickness is 0.2, if I put it on one node, it applies to all of them, that's fine. If I'm using ANSYS 13, I've got to use section, shell, layer, add layer, to put the thickness in. So I've done all that. I'm now going to create my model. Click on work plane, change active CS to global cylindrical. It's fine. And I'll click on preprocessor. I'm looking for create modeling, beg your pardon, modeling, create nodes, create nodes, and active CS. So the first one is node 1, its radius is 30, which is correct there, its angle is minus 90, and its Z direction along the longitudinal is 0. We put that in there, and we press apply. We then pick on node 2, which is a radius of 30, an angle of minus 75, and a Z of 0, and then we pick on node 3, his radius is 30, the angle is minus 60, and the Z is 0, it's fine. You then pick on node 4, where the radius is 33, the angle is minus 90, and the Z is 2. We put that for node 4, 30 minus 90, right, and then pick on node 5, So the radius is 33 and the angle is minus 60 and the Z is 2. What's that? Then we got node 6. So the radius is 30. The angle is minus 60 and the Z is 4. So we press apply. We then pick on node 7 and the radius is 30. The angle is minus 75 and the Z is 4. Put that there. We pick the last node of the element, which is node 8. The radius is 30. The angle is minus 90 and the Z is 4. Press apply. Okay, that's fine. I want to look at this at a different angle. To put plot controls, pan, zoom, rotate, and I'm going to put ISO, isometric. I've got it like that, and I will now put my nodes in. So I'll pick on the first node, which is a cone. I'm going to create an element, of course, before I do that. So let me do this. Let me put elements, and we put elements auto numbered through nodes, and I'm going to pick the first one there, which is 1, and the second one is 3, and the third one is 6. These are corner nodes. The third one is 6, which is that one there, and the fourth one is 8, which is there, and 6, 8. Then I'll do mid-side nodes, and the mid-side node is 2, and the other another mid-side node is 5, and another mid-side node is 7, and another mid-side node is 4. And I press apply, and I've got my element there. I've got my element there, and I'm going to stop now because my camcorder only lasts for 10 minutes. So I'll have a quick break. So I'll start the camcorder again, and I'm going to copy the elements. So I look for copy down here. And there's copy, elements, where's elements, nodes, elements is there, elements, auto numbered, and I press that, and I press apply, and it says element increment is 1, number of copies is 12, node number element, node number increment is 8, and the offset is 30 degrees. So we press apply, and there we are. We've got our model, and that's fine. That is fine. So we can now we've got to we go for modeling again. So we look for modeling. We've got to compress our element, modeling, we've got numbering controls, we put merge items, and we press OK, compress items, and that's OK. And now what we've got to do is to, that's fine, we've got our model, we've got to constrain it, but I look at the plot controls there, and I put pan, zoom, rotate, and I'm going to put right, so the right side will be on the right, and the left will be on there, and I've got to restrain it. So I put on solution, and I pick on define loads, apply, structural, displacement on nodes, and I pick this box here. I'm going to restrain the right side, pick that box there, I'm going to restrain this here on the right, X, Y and Z are 0. So I come down like that, do that, and I'm just doing that. Oh. I'm going to make X, Y and Z 0 here on the right side, so I've got UX, UY, UZ, apply, and then I'm going to box it in again on the left side, so box it in there, and I go like that. I mustn't go too far over because I'm at straight mid-side nodes. Press apply, and I'm going to put all degrees of freedom on the left, X, Y, Z, theta X, theta Y, theta Z. Okay, that's fine, and that's fine there. The next thing I'm going to do is to put the pressure on. Now the pressure for the eigenbuckling pressure for this, so we put pressure on nodes. The eigenbuckling pressure for this, we'll box this in here, was about 8,000 megapascal. It was huge, so I've got to put in something a bit smaller than that, see if it works. We put in minus 1,000, and I press apply, and I press that there, and I'm going to stop now because when I do this analysis it might take 5 minutes, so I'm going to switch my camcorder off. So I'm resuming again. I'm going to do the analysis, so I put analysis type, new analysis, static, it's going to be static analysis. I'll put solution controls, and here I put large displacement, static, calculate pre-stress, time program chosen, it's got to be on, number of sub-steps, it's going to be 20, maximum number of sub-steps, it's going to be 1,000, and the minimum number of sub-steps is going to be 1, and then I'm going to press all solution items, and then I've got to turn this in so it does every sub-step, every end step. Right, every sub-step, right, I then pick on non-linear, and I'm going to pick on degree of freedom, I'm going to pick on and I'm going to put in maximum number of sub-steps, 1,000, and then I'm going to press OK, and I'll run it, press solve, count ls, and this might take 5 minutes, so I'm going to stop the camcorder. So I switch the camcorder again, it's done it, it's got a message there saying that the shape of the element is terrible, which is what you'd expect because it suffered material and geometrical nonlinearity. So we get around that. We then pick on the general post processor, pick on that, and we pick on read results, we pick on the last set, and we put plot results, and we pick on deformed shape, deformed and undeformed shape, and we get that. That's fine. So now we've got to do the history of it, the time history. So we come down here and we look for time history post processing, pick on that. We then pick on add data, and we pick on degree of freedom solution, X component, and we press OK, and that's done. We now move this out of the way, and we pick on a point there, which will give us a point, and we press apply. We then bring this back here and we pick on graph, and then we move this out of the way, and then it is collapsed at about 0.05, which means we used 1000 megapascals. It's 50 megapascals. That's the end of it. It's fine. So that's the end of it. Thank you, ladies and gentlemen.